Here a final construction. This is a 12-unit bridge based on 6 implants, and we have here the anatomical reduced tooth form. Both of the molars are monolithic structured, and all around the construction we have designed the gingiva. The final situation looks like this. So, and this is made out of either the choice zirconia or solid. So this is the result after our construction. The question is now how we get this construction, this result. We started with an ordinary indication. Both molars are anatomic crowns. The others are based on the implants, reduced coppings, anatomical coppings, and we have reduced pontics. There is nothing visible which shows me that we can create a design. When we want to create the gingiva, we have here a new tool. This will appear with the new update. You see here, normally it's this option. No pre-op model, no gingiva, no implant, no design of a gingiva. That's the standard. And when we want to create now such a restoration, we need to scan a separate gingiva, yes, implant-based, screw-retained, and design gingiva, question mark, yes. With these 3 additional options, we can do such a construction, what I showed you at the moment. So then, after the scan process, we get this information. This is our model situation. And we are creating here a new occlusion. That's why we need to start the articulator. And I hope you can now follow. When we have no table available like this here, you will never get natural front teeth. Because when I start the movements now, then it's moving against this pin on the table, and we have a flat occlusion plane. This makes absolute no sense. That's why we need some information from the patient side. These are the same information what we have done this morning. Length of the movements, maybe only 4 millimeters. I'm now playing with the values. And here, Bennett angle, 6 degrees, 5 degrees. immediate side shift 0.1, 0.1, 46, 42, and now we need this table here with the canine guidance with 36 degrees, and maybe here 34 degrees, and very important, the inclination of front hip guidance with maybe 47 degrees. Now the construction can run. Otherwise, when we are missing such information, we are working in average values, we are creating a wrong occlusion, and we will get no guidances in the front. What we are doing here is a construction which takes us around 2.5, 3 hours construction time. It's not done in a few minutes. It's a very complex construction. That's why I have prepared several steps where we can go a little bit faster through the construction. You see here who was doing, from the technician side, who was doing a case with implants already? Okay, then you know it's a different workflow between a normal ground construction and this construction on the top of the implant. We have no prep line. We have at the moment no cement gap, nothing. Exactly. What we need now is to detect the position of the implants. We need the original scan bodies. Yeah, exactly. In this case, it's range 5. With the diameter 4.8. In the front, we have used another range. Range 6 with 3.5 millimeter. So we think, wait a second, okay, that's right. 3 millimeter here. We got it here. Confused, sorry. We need to detect this position, that we get the insertion direction and the position of the implant itself. So here we have to detect or to draw the emergence profile. We cannot make an emergence profile because the implants are, all the implants are above the gingival situation. And we cannot make a negative emergence profile, that's not possible. It's a training model. Don't think about the position of the implants. It's just to show how it's working with the gingiva itself. So we can continue from tooth 1-6, next 1-4, next 1-1, next 1-2-1, 2-4, 2-6. So and now we get the teeth. I will change the teeth from the normal average mind form to the crude teeth. And in that moment I have to leave the wizard. I will go to the expert mode. And then I will change, load custom tooth models. Here we have the Klug-Miller mind forms, the oval, the rectangular, or the triangle. You will see now what happens here in the background when I click on OK. There's always a question, a safety question. Do you really want to change? Because theoretically you can play with the software, and if you don't like it, you go backward, just choose another one. So we have to say, yes, I want to change. Now we have the Klug-Miller teeth on the surface. So, now we have very, very important information to talk about. Where we have implants, implant positions, we need to choose in the database a tooth as a construction type. Yeah? An implant needs to have a tooth as an indication. But when we want to design a gingiva around the teeth and the pontings, the tooth position is more or less wrong. We want to be flexible with the adjustments, with the positioning. That's why we get now the possibility, this is not available with the last version. We can make the teeth into pontics. There is an option to say, right mouse click, free screen, library models to pontics. Yes, I will do this. Okay. And you will see later on. You will see later on, when we fix the teeth on the individual position, we are moving upward, we are moving backward, we are rotating, that this screw channel here will be between the two teeth in the middle. And when you calculate, when you don't switch into pontics, when you calculate later on a tooth onto the abutment, it looks the tooth neck like this. That's not possible for the gingiva. That's why we are now complete free, and you will see in the middle between the two teeth we have the screw channel, independent from any positioning. You said, wow, that's really wow, that's perfect. Now it's closed, this problem is solved. So, for the moment, this tool is called tooth placement. I don't need the screw channels. That's why hide it. I will look for the antagonist. Oops, there is no contact, nothing. So, we can now move tooth by tooth into the right position. Exactly. This takes time, it's very complex. That's why we have now in the tool a new possibility, the so-called chain mode. The chain mode is really a virtual chain connecting all teeth together. That's now the new development. It took around 2 years to get this chain mode perfect.
Ja. Da haben wir 2 Jahre dran gearbeitet, dass es so funktioniert, wie wir es jetzt haben. Zusammen. Nur damit man sich vorstellen bekommt, was da an Arbeit drinsteckt, wie sowas hier beim Klicken alles funktioniert.
So, this is the chain mode. Just an example, what makes sense to do here. This is my first good position of the front, and I will move the teeth for the model situation onto a fine position, maybe 1 second, like this. Then I will do an additional custom view, renaming front. Then I can rotate and move, and when I go back to front, I have always the same view. Because the chain mode at the beginning is a very rough movement. It's just a first move. In the tool itself, we have the chain mode, where we move everything together. Or we can switch onto single, and then we can move single positions, but with the help of the chain mode we cannot lose the approximal contacts. I can rotate but you see always we have some contact, the other teeth are also in contact, so we are permanent, or we are completely sure that this movement is on one chain. I can unlock the chain. Wait, sorry. Then I can do separate movements like this. Then we have here a tool which is called symmetry. Wait, I have to activate. And then we can move two teeth together and they are moving symmetrically. I show you now how to play with the instruments. To handle this perfect takes you 2 days training. Ja, üben. Nicht einfach nur, wenn ihr das deutsche Wort nicht üben. Genau, Übung. Because you can also move the molar, then you can say there should be also symmetrical movement here. Then you can move both of them. Or which one? Of course, we will check always the occlusion. I have only one contact at the moment. So we will oversize now the grounds.
Symmetry.
So this is now, I would like to say, playing with the position till you have the right occlusional surfaces. In the past, with the last version, can you imagine, you have been here and you moved every tooth single, step by step. And now you have the possibility, if you get the basic information about the occlusion, now you can say it's fixed with the chain, and then I'm going back to the single mode to adjust the occlusion step by step. And don't, yeah, or I hope you can imagine. Yeah. With this tool here, this disc on the end, you can rotate, and you can increase or decrease the center. You can increase scaling the teeth itself. And when you have finished all the movements and you will do a small adjustments, finally you have here also a possibility on the tube. It's like a rail. This is for the last finest adjustment.
מעניין, זה חיכי ווקט.
So, when the teeth are in the right position, then we should look and then we are starting with the bottoms of the buttons. Here we click to the next because we don't create the buttons. And this is now still the case where we didn't change. It's just now that you can see the difference. Here you can see where the tooth neck is going to when you are in the wrong position. That's why we have here complete different positions of the teeth with the abutments below. So, after positioning the teeth and the measurement against the gingiva, we are now starting with the gingiva design. And the gingiva is something like a splint. We will block out the surface here around the abutments, and we can also check the undercuts here with a little bit changing the intersection, the insertion direction, And then we will generate now the bottom of the abutment, of the gingiva, This means we have also to protect the surface with a thin layer with 30 migrants around here. You see it's moving here a little bit slowly because we need to cover the whole model situation. We will block out the region around the implants, making sure that the gingiva will have not a wrong pressure against the natural gingiva. You have seen at the beginning when we have adjusted the teeth from the library, there was a huge distance between the teeth and the original gingiva. And this region will be filled out with zirconium in form of the gingiva. But the surface of the natural surface we will protect with the thinnest layer. This is now calculating here. And then you will see see here the fine layer. In the next questions what we have, how can we make sure that the patient will be able to clean the region here? So there is the free-forming tool. And here we can add some material to block out small channels for these small brushes. Oder für die Munddusche, dass sie da reinkommt. Of course, it's a little bit rough. Here we have, it's not so good. This we are doing all around the TI buttons. I will stop after this tool takes too long to show every detail, but that you can imagine what details are coming up with this tool. We are going to the next step. So, you see the position of the tool looks good. We are talking about pontics, they have contact, more or less contact with the gingiva, the original gingiva, and now we are creating, because we don't want to have these long necks. Now we will create the gingiva, maybe in this height, against here this surface. And therefore, you have seen this before with the splint. We will sign up the dimension. This needs at the beginning a little bit more space for the calculation. Later on with smoothing you can reduce the surface, you can make it fine and round. Now apply.
شو استفدنا من هاي اللي ببرزوها؟ تعال سكرها بقى. شو السبب؟ شو ممكن؟
So this is now the surface calculated from the software. It's not finished at the moment. Now we get the free-forming tool, and here you can play with parts, with bigger parts, freeforming means you can add by hand. Then it looks more natural. I will go to the next step. Here we have filled the approximate contacts. And now you see here, maybe this is now playing with this form. You can really use this region and say make it more individual. Here, this is such tools are more or less tools for adults when they want to play. You can do this. If my dentist would like to have a soft, a smooth surface, I don't want to do this. But in general, it's up to the individual surface what we want to have as a final result. That's smoothing in this region. So, this is now a next step what we can do. Either we have the possibility to stay with this volume of the gingiva in zirconium, or in this case you can do the shrink. No, sorry, this is the shrink for the teeth, forget it. I'm wrong. I'm not familiar with the workflow. You see here I get the option to make the shrink, and here I can paint the approximate side. Okay, we will cut back. And I think in this case I have no cutback library from Fluvido, but I will show you the solution from Fluvido. So it looks like this. This is now a handmade reduction where we can laminate the ceramic resurface here, or we have done already the cutback with the help of good Miller teeth. This is something what you can also import through Miller cutback teeth. Then you can choose for the cutback automatically the form of good Miller. This is an additional tool what's available, but my dongle here is not activated for good Miller cutback. That's why I show you the final result. So, it's the same what we have done before. We will cover the premolars with ceramic, and the canines, they get a stable palatinum side in zirconium, and only the buccal side will be laminated with ceramic, and the incisals, they will be laminated from the incisal guideline here. This is done out of zirconium, and from here on you can see the small angulation here will be covered with the labial side to the front. This is always the decision of technicians. How strong you are following your how can I say? It's up to the technician to decide how to install the aesthetic. Never in my life I would like to follow here with a monolithic structure in the front. This looks not good. That's why we are reducing more or less the labial side, but from the palatinum side we can stay with the surface. This is always the decision of technicians.
Sorry. No.
So, the teeth are shrinked, and when I clicked to the next, I get nearly the same tool. This is called shrink gingiva design. I told you this is the gingiva, handmade, individual. It could stay in this size, in this position, or you would like to say, I will go backward, I will reduce this surface, and I will individualize this with ceramic or with acrylics. Also, the question of aesthetic, what kind of aesthetic we are following. As more individual, as more hand work you have to do after the milling and the sintering process. Because when this is on this surface finished, you have to do nothing polishing. If you are reducing it, then you are working with the next materials against the new form that you will create your own surface by hand. So I will reduce now the outside of the gingiva with 0.5 millimeter. Of course, on the palatinum side, it's not necessary to reduce. Because there is the question from the aesthetic, not the biggest problem or the biggest challenge. So, apply. Now I get this from the front view. There is always around the neck of the tooth the safety zone in zirconium. After the milling procedure, you will use a handpiece and you will smoothen a little bit, but then you can protect the tooth neck with the help of this borderline against radiations or against abrasions. Ja, das ist so gedacht. Wenn ich da beim Schrumpfen das reduziere auf 0, dann hätte es ganz knapp an der Gegenwartgrenze auch. Und wir haben festgestellt, so ist es besser. Still, as an information, I think you can see here we have still part of the tooth. At this moment, the gingiva and the teeth are not one unit. They are still single from the construction side. Gingiva is reduced. Now we are coming to the connectors. Sorry? Good question. The question was, why do we need connectors? The software is stupid. The software shows you always, because we have to do a workflow. The software is coming to a tool which is called connectors. The software says for the first moment there are the connectors. From now on you have here additional tools.